Okay, we're back. I just had a little session with Eagle and scripting. That was very educational. You could just go in there and change things around until you figure it out. And one of the things I like about that is, um, unless you're really desperate, I don't think you need to read the directions. But there are enormous numbers of directions on this. I mean, I've got a big pile, a stack of papers in the back. That's all documentation on the Eagle user language program. So if you want to, you could read the directions. But I find it much more educational to just poke at it and see what happens. From a programming standpoint, um, fractals are just not that complicated. The algorithms are just not that hard. From a, I'll put it a different way. From a photo plotter standpoint, it's very compelling because printed circuit boards are a great output device. But if you don't want to use Eagle, you can just make boards in the back of the room with ferric chloride or ammonium persulfate and just etch them. All right, last time we talked a little bit about the PowerPoint slides, and we went through problems that you guys might have. One thing I think that makes sense is for you guys to think in terms of outlines. And what happens with outlines is people lose their place. And you like to show where you are in terms of the outline. So the first thing he says is make your first and second slide an outline of your presentation, and then follow the order of your outline, then come back to the outline because people don't know where you are or where you've been. So if I said to you that I was going to do a formal structured outline, I would number and then subnumber for all the major points and all the minor points. And then every time I finished one of the major points, I'd bring the outline back up and say, here's where I am in the outline. And I'd use some scheme to indicate that place in the outline, like the color. So for example, let's do an outline. Right? So the first point I want to describe for you is the pain. Right? So this is the pain that my my system tries to address. People have so much trouble running wires into their brains in order to be able to power the eye prosthesis. So in order to power the eye prosthesis, because I can introduce infection if I have wires going into the brain, what I do is I surgically implant the eye prosthetic, and then that transmits video signals to the brain. And so I have to power that whole thing without batteries because I can't keep opening up your head to put in batteries. Therefore, I need to use wireless electricity. And maybe it doesn't use a lot of power. And then I want the sustainable competitive advantage. Nobody else does this. I've got a patentable device which I can apply for that'll give me a biomedical device that nobody else has. It's very efficient at low power and high frequencies. And now I can power my biomedical devices. And other devices too. The Ryan yo-yo meter, which may not have a particularly important societal implication, but instead it gives me a device I can easily bring to market. And maybe being able to bring a device to market and sell it is a far more compelling thing, because if it's a biomedical device, it's very difficult to bring it to market. And then what I'd like to do is talk about the market. And so now the market might be in terms of the ultimate market and the preliminary market. So now I've got the preliminary market, I've got the ultimate market, right? And now what I'd like to do is I'd like to talk about this pane in terms of the general problem. Let's say it's, what is it called? Um, the framework, right? We're building a general framework for transmitting power. And then the other thing is, we'll call it the preferred embodiment. And for that, I might say what I really want to do is use it for, my biomedical devices, but in general, I can come up with other embodiments that I can bring to market more quickly. So then if I have this thing, let's see, what did I just do? I want to take this whole thing, copy it, and paste it. And now later, I'll say, here's where I am now. And maybe I'll make that highlighted and then talk about the pane. Now take the whole thing, copy it, and paste it. And actually, I don't want the colored one. I want the non-colored one. So we'll go in and copy it, paste it 3 times, right? So in this one, we'll highlight the advantage. And then we'll spend our time talking about the advantage. In this one, we'll talk about the market. So we'll keep coming back, right? So now in the intervening one, where as I go from market to advantage to, from pane to advantage to market, I'll have several intervening slides, but then I'll come back to the outline, and people won't be lost. They'll know where I'm going. They'll know where I've been. And, normally people lose their attention span after about 5 minutes, unless they're experts in the field, in which case they lose their attention span in about 10 minutes. So how do you deal with that? And the answer is you kind of organize your talk a little better. So putting an outline together for your talk is very helpful. People like that. Using simple colors, 1 or 2 colors, and then being consistent with your color choice and your font is so important. And that's how I like to think about the outline. It comes in at the end with some sort of conclusion, but presumably a formal outline has, major points and subpoints. And if you want, you can number them, right? I mean, you could probably have used letters and numbers, or Roman numerals and Arabic numerals, and then some combination of the two if you like. I don't know how many subheadings you need. But that's kind of the way I would like to see your talks organized. Everybody should write to an outline. I've tried writing books without an outline. It's not pretty. They go on and on. You never know when you're done. But when I write a book to an outline, it comes out like clockwork. And the same thing's going to be for your thesis. You just got to outline your stuff. At some point, you're going to have a research outline. Call it a research agenda. And now you might start it off by devising your plan of attack. But if that's the case, you've already lost them. What you really want to do is you want to start with the goal. Give them the punchline first. My goal is to obtain, let's say, validation. You want to validate your theory. And so you might have 2 kinds of validation. Validation by simulation or by theory. Let's say a proof. Maybe you could have a proof. Maybe you could have a simulation. maybe you could have an experiment. So first you want to establish the theoretic foundation. The proof may have the ability to do that. The simulation will give you some kind of mechanism whereby you can make these claims look like they're real. And then comes the experiment, which hopefully validates the simulation. And if it doesn't, then you've made a discovery. You've found out what doesn't work. What else do you need for your simulation? Some kind of summary. Your goal may also be, let's say, after your experiment, what works? What didn't work? And what's the future work? There's going to be stuff left. You might say, gee, you know, I did this thing with my variable pitch turbine blade. It's actively controlled, and I'll tell you what doesn't work is using servos to control the blade angle. That just doesn't work because the servos get all screwed up. The only thing that works is DC motors. Or the only thing that works is, you know, Arduino. Made that up. Some things may, you know, you might say nanowires don't work for controlling, the micro muscles for moving the fan blades around. That just doesn't work. There are different kinds of servos. One is called a nitinol wire-based servo. I've got a bunch of these in the back. That is behind George in the drawer. And when they heat up, they contract. They make nano muscles. And they may be used for controlling your fan blades, but maybe they don't have enough power. So maybe that doesn't work. So I'm thinking this for your talk next time. We're going to bring in the outline. And that outline is going to be used to describe your thesis proposal. And it's going to include a research agenda. Maybe it'll include something from this talk that we did today, the pain, the advantage, and the market. So a research agenda outline and an outline that has to do with the general overview, the motivation. It's a motivational outline. Right? So your research agenda in outline form, put it that way. Your motivation in outline form. It'll help you organize your talk a little bit. And then you can have an outline that includes motivation, research agenda. So now I've got an outline that basically says, okay, in motivation I've got this other outline which breaks it down. And so when I get to motivation, I can sort of see where I'm at. Now I'm in motivation. Then I go to my research agenda, and now I'm in the research agenda. So you can see that next thing I want to talk about is my research agenda. And my research agenda is to give me validation for my hypothesis that combined electromagnetic fields will enable me to deflect protons and prevent astronauts from obtaining genetic damage at the atomic level by blocking ionizing radiation. Even though the protons are coming out at the speed of light. Nearly the speed. How 80% of the speed of light? Yeah, fast. It's electricity in a vacuum. I get it. Yeah, okay. And it's accelerated by the sun, right? It's a sunspot ejector.
Right, yes.
Okay. But is cosmic rays also protons?
Cosmic rays, I think they have to be
Neutrinos.
neutrinos.
Neutrinos, you can't stop them. They go through everything.
But they're also very hard to detect.
You can't detect them, you can't stop them, you can't deflect them. Will neutrinos cause genetic damage?
I think a number of them will.
They pass through everything.
Right.
There's just nothing you can do to stop them.
More or less.
What's a distracting animation? If you had an animation of computational fluid dynamics, that would be fine. In one thesis, this one here, this was computational electrodynamics, and there was a validation. So that's the one that's described by Bob Distinti in his work on my website. And that's a very nice outline as well. So it's got the theoretic basis. Then he's going to have the simulation for validation somewhere. Right? He wrote the software for that. So he wrote his own software and did his own simulations. He wrote that software for, I guess you'll call it computational electrodynamic software. And then he built the jig. That looks like something you could do Wetricity with. Maybe you and Bob should talk. He works at Norden, you know, where they build the radar systems. He's a radar engineer. So, you know, in this case, there's a lot of detail. He shows you how to build the brass screws for the terminals. He shows you how to hook it up for his little, he bought this just to do his own experiments. This is an inductance meter. Shows you how to build the wooden keeper. It holds down the board. That's like a woodshop project. It's good stuff. And then he summarizes the experimental data and shows how it validates his work. And there's future research. And then a bunch of citations. And that's like a decent thesis. And you have to defend it in front of the faculty. So we'll be putting up those posters, and then you'll be presenting just like you do here. Only they won't be as nice as me. So if I gave you a hard time today, just keep in mind it gets worse when you get in front of other people. So I'm thinking of another. Yeah, we could say it. Another presentation. So I like this because it gives you an active learning experience. When it says it's your turn, this is something for you to do. And so what I thought would be fun is if you guys could work on your PowerPoint presentation a little bit. But in parallel, I think you have to keep in mind that I need a final. It's now April 16th. Your final is going to be due on May 7th. I think that's right, isn't it? Isn't that the last day of class? I think so. So what that means to you, the student, is it's time to really get focused on your writing. So I need two things from you. I'm going to need your presentation, and I'm going to need your midterm to get expanded a little bit with more writing to address some of the problems that we've had. So I'm almost thinking that your midterm needs to be submitted again for another pass by me, because you all need work with your proposals. None of your proposals are ready for a thesis proposal. None of you are ready to go on and do a thesis based on what I've seen. So you're going to have to essentially identify your research agendas, make sure that you've isolated the contributing work for your field and what it is you plan on contributing. That has to be clear in your outlines. So what possible questions could your audience have? First, obvious question. What's your contribution to the field? You could even start with that, but I like starting with the pain. Maybe it's good for the significance part. When you do the significance, you might say, and my contribution is. Your research agenda. I have this idea that your research agenda should have very specific outcomes, and you are going to assess those outcomes. So if the outcome is this data, I should be able to interpret and summarize the data and show how it supports my theory, how it either disputes it or validates it. You can even plan that even though you don't have the data, you could make it up. We will derive data that shows an X% efficiency increase when you control fan blade angle for power transfer. And then what will the conclusion look like if you find that's true? What will audience members ask? Did you look into this topic? Did you look into that topic? What about the guys who use airplanes to control pitch? And they have turbofans. Don't they do pitch control of turbofans on airplanes? You can say, yes, they do. Well, don't they use computers for that? There they can. Or they could just use a throttle. And so don't people already know that you can change the pitch of a fan on an airplane and get better thrust? And the answer is yes, but they're making thrust, they're not trying to capture wind. So what I'm doing is different, because what they did was to try and push air. What I'm trying to do is get pushed by air. So it's just like what they're doing with a difference. It's kind of a big difference, because it really changes the design. Catching wind and pushing wind are really different. And it also is a function of the viscosity of the fluid. Propellers for boats don't look like airplane propellers because of the viscosity of the fluid. Maybe viscosity of air changes as a function of temperature. It does. Maybe the shape of the propeller needs to change as a function of temperature. Probably should. So if you've got this study that shows how air viscosity changes as a function of temperature, now you've got a theoretical foundation for making a compelling argument that your pitch angle has to change, not just as a function of incident air, but also as a function of the temperature of the air, right? Because viscosity's changed. This idea that you should have a nice outline and then you should show where you are in the talk is really very good, especially for a longish talk. And especially if you have lots of subheadings. Then you probably just want the major points of the outline, and then the detailed outline comes after with a heading that shows the major point, like we did for the overall talk, which described motivation and then research agenda, and then the detailed talk, which shows the outline for motivation, and then another outline for research agenda. So having multiple outlines might not be a bad idea. When people sit in the dark, like you guys are doing, watching these sorts of slides, I think it puts you to sleep. It's not easy sitting there listening to a sick person read PowerPoint slides. Please don't read your slides to people. That's really bad. I assume my listeners can read. Sometimes people like to use a master slide and make consistent style changes. That's very good for keeping fonts consistent as you go from slide to slide. All right, let me write up a homework for next time. Okay. So for next week, expand. So you got two things to do. You got your prior PowerPoints, which you've been doing all along. You're going to have to glue them together and organize them right, and then use outlines to get the organization correct. Insert your outlines using color or some other means to indicate what point you're up to in the outline. This business about your midterm, I think everybody here could improve the midterm. How many references are we up to now? I think 17? 18? If you're going to do research, you're going to have to learn how to design an experiment to test your hypothesis, whatever that may be. And it's perfectly okay to build a prototype. That's research by experiment. You know, that's great. Simulations are okay too. I want to know what it is you're proposing. What else? I think that's good. And just in case you're, in need of some sort of guidance on this, you should look at validation. And there's a whole section in here about validation. Experimental models for validating technology. And this is the way in which you can provide mechanisms for showing that what you're doing is valid. Right? How to make experiments that look convincing. Okay? So now you've got a little paper. So what do you think of that? It's not a long paper, but it gives you some ideas about what you can do for designing an experiment. Some people have said a thesis is nothing more than a research paper with training wheels. Nobody is born knowing how to do research. So this is the time when you get to learn how to do research. It says it's hidden. Why is it hidden? Huh. Okay. I just want to make sure everybody gets this. So we'll send it out. So it's clear, right? I'm going to look at everybody's draft. I would like to get hard copies. But I wrote if you can. The safe assumption is this printer is not reliable. It's always out of paper, or the paper looks crappy. And I can't vouch for the reliability of the paper of the printers in the galley either. So print your stuff in advance. Otherwise, we end up printing it here, and it's a pain. It's very distracting. So if you can bring a printout with you, that's much better. Well, that's what I have for you today. Sorry that we started a little late, but we went over a little bit, so that's probably okay. And next time, if we go over a little bit, we'll make up for the few minutes that we started late today. So we'll just keep going over a little bit until we make up all the time. I think we went over perhaps by 10 minutes, but we started 30 minutes late. So actually 12 minutes. So we'll try and go over by 12 minutes next time. We'll make it up in no time. Okay, thanks a bunch. Does everybody understand the homework? Thank you. I think I just saw somebody open it. It's not open. the terminals and go to the relay. So, do we have any documentation on that relay?
Yeah, I'm pulling it up right now.
Yeah, what's it say on the relay?
On the relay?
Yeah.
Phone number?
Yeah.
SRD 0.5 EDC SL
SL.
C.
That's not good. I'll get a Yeah, but I mean, this relay should have a data sheet. So even if it doesn't, we can scope it out right on a daily basis. It's here. And just closing the relay up, see what it takes to close the relay. But if you could find a data sheet for that relay, that would be very helpful. See that's normally closed. That's normally open. So I say these connections are made when the relay is closed. I gotta find the data sheet for that. Is this it?
Zero. Yeah. Oh. I will redo this edition for the next session. I will make
Yeah, that's due. That you'll have to fix that.
yes,
And if you're looking for extra credit, I say, yeah, this is terrible. If I go and try and get this again, will it work the second time? Yeah. You have to load everything twice. That looks like your relay to me. How many volts is this thing? So the layout's probably the same. So you got a common and a switch that goes back and forth, and then this part, which is a coil. And what you can do is you can measure. First of all, you got to normally open versus normally closed, and you probably want the normally open since you're just going to switch it on and then turn it off. What else can I do for you, Raoul?
maybe this is great for what if I redo this.
No, I want you to do a little extra work.
I'm not sure if I can succeed with the.
Well, I'm not sure if you can either, especially if you keep arguing against doing it.
I will
Why don't you try it?
Yeah.
Otherwise, what's going to happen is I'm going to end up calling your mother and asking her if you've always been stubborn. And then you know what she's going to say, right? Yes, he was that way when he was little. And then I'll say, well, what can we do about it? Nothing. I'm very sorry. I sent him to you stubborn. Well, I don't know if you can succeed either, but if you don't try, I know for sure you won't succeed. Give it a try. See if it works.
So, firstly, shall I just redo and submit it?
You do need to do that. That's due next week. Everybody's redoing and submitting next week. No, it's not for the midterm. It's for homework assignment.
Yeah.
We're taking the midterm, we're resubmitting it for... You've got to change the way you've been doing your citations, for sure.
So,
You want to rewrite that in your own words. I think if it's your abstract, you don't need to quote excessively from some paper. I don't think so.
So, what I can do is like I will redo it and submit it by midterm, and I will start the program.
Yeah, give it a try. See what it's like to do some programming
Yeah.
in SLP.
I already installed it. And
I just played with it for 2 seconds and I thought it was fun.
Yeah.
So you could try it.
Yeah.
It's very fun.
So,
And education. And if you want, you can grab the documentation off the back of the counter there. But I think it's easy enough to just sort of look at the code and try and muck about.
for the fractal.
Yeah. The fractal.
Okay, so I will firstly I will just redo it and I will upload it.
I think it's a very nice market. If you identified the biomedical market, low power, and you're going to transmit. I love it. Catch you later, George. See you later.
Take care.
So I think that's exactly what you should be doing. I think that's a great idea. I'm not at all bothered by the idea that it works, but only for low power. I think that's very fine. That means you can make more efficient antennas that are smaller,
Yes.
work at high frequencies, work for biomedical devices, which have very high profit margin. It's very interesting.
So this is fine, right?
I like the thesis. Okay? I like the ideas. I just have a little
It's
trouble
just,
with how you do proper citations.
I don't know about how to put. I mean, I never wrote a paper, but
I know, that's why I
India,
went easy on you.
yeah, in India it's like we never do this.
Well, I know, but it's a mistake. You don't have to do a little writing.
Yeah.
And no one was born knowing how to do that kind of job. So that's something that you're going to learn. I think that's a very exciting thing. Okay? I'm sure you will. Thank you.
So that's what. Will go with the scripting and I will start my
Yes, please.
I will.
See if you can make the script work for us.
Yes. So and also I will read it and
Yes, so that's the next week.
now about
I'm not finding this conversation productive. You can't just submit it again for the midterm. The midterm is done.
with the same business, putting it to the citation.
All right. We must put the changes. We must put in citations. It will not count. We will put it clearly for one minute.
Just for the
It's for the next exam. Okay? There's going to be that phone call. Everybody's going to say, I have this terrible phone call. Right? That's the line. Since you're very struggling.
This is like a very good answer.
I understand, but listen, don't worry about it. It all comes out in the end. We raise the marks in general as the all our homeworks are done properly. And then when I see the final report, the overall grades. So I'm not like a machine where I'm just very everything I put. I want to see improvement in this group. The homework grades will pull up the overall. Not everybody gets it.
Yeah, that's for everything. Thank you.
Thank you. So what I was thinking is this, that we need a battery to, there's just a little bit of, question in my mind about, here's your, all right, so, instead of hooking 120 volts, I think it would be just fine if we hooked up a multimeter. Yeah, I'm having a little difficulty hooking to these screws. I'm not sure why. This is when it's tightened down, it just pushes the cord back up. All right.
SEO programming classes?
Lecture demonstration?
Just straight lecture or mostly demonstration?
I have I mix. Like I have a whole bunch of PowerPoints, but when I talk about these things, in general, oh crap! I've been